Hello guys, and welcome back for another video. And in today's video we will be deriving the equations of motion on a graph. So let's start with the first one. V equals to u plus at. This is probably the easiest equation to derive here. So first of all we will make our graph here. This is a simple distance time graph, and this is a slope, and let's make this also. Okay, so now I will explain you the components of this graph which will apply for all the equations in here. So this part, as you can see, this one is the slope here, and this part is u, initial velocity, because this part is the amount of distance traveled in time. So let me just go. This is distance, this is time. Okay, so this area is u because this is the amount of distance traveled in a given time, and this is v because this is the final velocity. This is the initial velocity, and this is the final velocity which we are reaching at the end of our point here. And this here, you can guess, is v minus u, because as you can see, this is v and we are subtracting u from here, so it is v minus u. This is obviously time here, and this whole everything which is under a distance time graph is distance, by the way, if you did not know, distance or displacement, but for the simpler sake we will say displacement here. And now that you know the components of the graph here, we will begin with our first derivation. So first of all, I will make the map, I will make the graph a bit more cleaner for you to understand. Okay guys, so I hope you can clearly understand the graph here, as you can see, and I have also labeled the points here A, B, C, D and E, so to make it easier for you all. And we will begin with our first derivation, and it is a pretty simple derivation as compared to the other ones. So first of all, we will begin by obviously writing the given, which you should always write. Okay, and first we will write time. What t here is dc, and also one more ab, because as you can see, it is also time. And we will write v here, which is ce, u, which is ad, and v minus u, which is eb. Okay, so now that we have written all the givens here, I hope you can understand, because I am going to erase everything because we don't have the space here. So let me just erase this, and now now we will begin with the actual derivation here, the main derivation. So let's start. So we know, you should know actually, that slope is equal to y by x. And you are asking what is, you might be asking what is y, what is x. Y is generally the height, and x is the base. Okay, so in our diagram, in our graph here, I need you to find out what is the height and what is the base. The height here is eb, because this is the slope and the height here is eb. Okay, eb by our base here, and our base here is ab. So now what is the value of eb? The value of eb is v minus u, So we will substitute in v minus u, and also the value of AB is t, so we will substitute in t. So let us do that now. We know the slope here is equals to v minus u by t, and you know what else is v minus u by t? Well, you guessed it right, it's acceleration. So we can write here a equals to v minus u by t. So now the derivation here is very simple. We can just do this: a by t plus u equals to v, and here is the derivation. And why this? Because as you can see, t here is in denominator place, so we need to multiply it by a, and we can see u here is negative, so we need to make it positive. It's pretty simple, and that is the first derivation. Well, you can also write it as v equals to u. You can also write it as v equals to u plus at, but it's the same. Okay guys, so now we will begin with the second equation of motion's derivation, which is little bit more harder than the first equation of motion, but it's not really that complicated at all. And we will not write the given again, as we had written it before. And so first of all, we will begin by, we already know that a is equals to EB by AB, right? EB by AB. So we know that AB's value is t, right? So A is equals to EB by t. So hence AT equals to EB. Now you may be asking, why is this significant? Why are we even doing this? Well, this is a pretty important part of the equation, and we will need to remember this. Okay, so this is our first equation, I guess you could say here. And now we will begin our actual equation, our actual derivation. And as we all know that the area under the slope in a distance time graph is s, or distance. So we know that s should be equals to the area of triangle, let's write it a triangle, plus area of our rectangle, as you can see here. So what's the area of a triangle? It is a pretty simple. AB, it is as you may be knowing, the area of a triangle is 1 by 2 base into height. So first 1 by 2, and the base here is AB into EB. Okay, now area of rectangle is pretty simple. We can write it as DC into CB, because we know the area of a rectangle is length into breadth. Now we have written that as well, and now we will substitute in the values. So here is where we need to use the equation we had used before. 1 by 2 AB is our time, so we can write it as t into EB. We had proven it earlier that EB is equals to AT, so we can just write it as AT plus what is DC? DC is our time into CB is also known as U, or U, initial velocity. So if we tidy this up, we will get S equals to 1 by 2 AT squared 1 by 2 AT squared plus UT. You can also write it other way around, it does not really make that big of a difference. And here is our second derivation for the second equation of motion. Okay guys, so now we will begin with our final equation of motion's derivation. So this one is a little more tricky here, and so you will need to pay a little more attention here. So first of all, we will begin by writing the first equation of motion, v equals to u plus at. Why is this useful? Well, we need to make a value for t here. So as you can see, a is multiplying with t, so it will come down as denominator of v. So, and as this is plus u, because there is no minus side here, when we transfer it to the other side, it will turn into negative. So the equation will come as v minus u by a, and this is something you will need to remember here, as you can see, because this will come in use later in the derivation. So in the third equation of motion, for we know that the area under the slope is also known as distance. So you can see that the shape under here is that of a trapezium. I hope you can see that, but we know that the trapezium's area is 1 by 2 height into the sum of parallel sides. So what are the parallel sides, what is height here? Let us substitute here. Height in case of our trapezium here is t, because you can see this is our height. We can write it as t, and our parallel sides here are CE, EC, and AD. So we can write them EC plus AD. And what is EC? What is the value of EC and what is the value of AD? 1 by 2 t. EC's value is V plus, and thus, as you can see, AD's value is U. Okay, so here we have something at least similar to the equation of motion, but it is just not there. We can see that it is not in its final form yet. So let me just write it again. Okay, so how will we make this turn into our equation of motion? Well, it's pretty simple. First of all, we had written the value of t here. We know it as 1 by 2 v minus u by a, because we had proven this earlier, into v plus u. Okay, and so from here on out it just becomes very simple, because we already know that that a minus b is a minus b into a plus b is also known as a square minus b square, and in our case here a is also known as velocity and b here is known as initial velocity, so it is u, and we can multiply a by 2, so it is 2a. And I think you can see what I am getting at, because the equation of motion now is almost complete, only a little bit left. S equals to v squared minus u squared by 2a, and now it is very simple. We can just, as this is in the denominator place, we can if we transpose it to the other side, it will multiply with the other variable here, and here is our last equation of motion, and you can write it any way you want, it is not wrong. And that was it, and this was the last derivation of our of today's video. And if you have any questions on derivation here, if you want any clarity, you can just ask me in the comments and I will make it clear for you. Thank you and have a nice day.